Assalamualaikum warahmatullahi wabarakatuh. My name is Naila Zura binti Sari and my number is AA21160. Now I will explain about flip-flop. Flip-flop is a circuit with two stable and has the ability to storing the state information. It is also known as a bistable multivibrator. Flip-flop and latches commonly used in digital electronic. Flip-flops now only use the electronic time circuit and the simple one usually known as transparent latch. A latch employs a single trigger to store unlimited quantity of bit, while flip-flop only accept one bit of data. To prevent misinterpretation, the words add trigger can refer to flip-flop, while level trigger refer for latch. And there are four applications of flip-flop that contain counter, data storage, data transfer, and register. Counter is typical component in digital electronic and system. In digital electronic, counter is a circuit that generates a particular count sequence continuously, or data storage, a flip-flop in digital circuit that store one bit at a time. All that a register can do is store data for a number of bits, with each bit flip-flopping information for one bit, either 0 or 1. For data transfer, the ability to move or transfer data internally without changing the order of the bit is using a shift register. Data can be stored momentarily using the shift register. For register, it can hold several bits of data, and in digital, it's known as a piece equipment that stores data. Now, I will explain about counter. Counter is the flip-flop that can be used in a number of different ways based on the clock pulse. The counter's output has a preset state. One can count the number of pulses using the output of the counter. Counter has two types, that is synchronous and asynchronous. Synchronous binary counters include both sequential and concatenated logic element. Because the clock is given simultaneously with each flip-flop, the synchronous counter is also referred to as a parallel counter. Asynchronous, also known as ripple counter, since just one flip-flop is connected to the input clock and the clock of the following flip-flop are produced from the output of the former flip-flop. For SFM or finite state machine, the meaning is sequential circuits and is regarded as an asynchronous counter with an unpredictable sequence. There are two categories of SFM, that is Mealy machine and Moore machine. For the design of state machine, it contains state diagram, state table, excitation table, KMM, and circuit implementation. For register is occupied with flip-flop. A large number of bits can be stored by joining numerous flip-flops in the storage capacity. Function of register are data movement and data storage. And last but not least, the example of application for counter is digital clock. For register is cache memory in CPU. And lastly, for SFM or finite state machine, the example is video game. That's all from me. Thank you.
Okay, hi, Assalamualaikum. So I will continue to present the circuit implementation. So as you can see, this is our circuit. So we draw it based on the input that we get from the camera. Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sharul. So today I will present the simulation of the first question, which is question A. So, as we can see in this circuit, we have 3 IC, right? Which is this, and then 3 IC is split of 2 JK flip-flop and 1 IC and gate, right? Then we also use 3 LED. Okay, the first one is first LED, second LED, and third LED. So I will start the simulation. So the first one is first LED light up, right? Follow the regulation. Okay, so this is the result. Okay, so that's all for the simulation. Thank you.
Hi, Assalamualaikum. My name is Muhammad Syami Aiman, and I'll be presenting the simulation of parallel in-shift register using 7476 JK flip-flop. For the first operation is the power up, and the output is 1, 1, 1, 1, and the output will be 0, 0, 0, 0. For the next operation is clear, and the output will be also 0, 0, 0, 0. For the parallel load, the input is 1, 0, 1, 1, and the output will be 0, 1, 0, 0. And for the next operation, which is shift right, and the first clock pulse will the output will be 0, 0, 1, 0. For the second clock pulse, the output will be 0, 0, 0, 1. For the third pulse, the output will be 1, 0, 0, 0. For the fourth pulse, the output will be 0, 1, 0, 0. For the fifth pulse, the output will be 0, 0, 1, 0. For the next operation is clear, and the output will be 0, 0, 0, 0. The next operation is parallel load, and the input is 1, 0, 0, and the output will be 0, 1, 1, 0. And the next operation is shift right. For the sixth pulse, the output will be 0, 0, 1, 1. For the seventh pulse, the output will be 1, 0, 0, 1. The eighth pulse, the output will be 1, 1, 0, 0. And for the ninth pulse, the output will be 0, 1, 1, 0. And for the last pulse, the output will be 0, 0, 1, 1. And that's all from me. Thank you.